Good morning, children. This is class 9th physics. We are doing chapter number 10, gravitation. Yesterday we did the universal law of gravitation, and the formula we had derived for the law, and the formula was F, that is force, is equal to, the force is equal to the constant G, which is known as the universal gravitation constant. Right, children? We saw its value also yesterday. That was 6.67 into 10 to the power minus 11. Unit was Newton meter square per kg square into mass of first body, mass of second body upon distance between the two bodies square. So suppose the distance between the two bodies d, so it was upon d square. So this is the formula for gravitational force. This is the formula for gravitational force which we had derived yesterday. So we all know this formula. F equals to capital G, M, that is mass of body 1, mass of object 1, small m, mass of body 2, upon d square, that is the distance between them. That is the distance between the two bodies, right? This is the formula which we know. Now, let's solve a numerical based on this gravitational formula. So this is your NCERT solved example. This is your NCERT solved example 10.1. Right, so let's start with the question. So question says that the mass of the earth is 6 into 10 to the power 24 kg, and that of the moon is 9.4 into 10 to the power 22 kg. So kg, children, these are the two masses. Right, children? If the distance between the earth and the moon is 3.84 into 10 to the power 5 kilometer. So this is distance. One mass you can call it as capital M, other mass you can call it as small m. And the value of G is given to you. What you have to calculate? We have to calculate the force exerted by earth on moon. So children, mass of earth, we are calling it as capital M, which is over here. Then mass of moon, we are calling it as small m, which is given over here. The distance between them, we are calling it as by the symbol small d, which is 3.84 into 10 to the power 5 kilometer. Now, kilometer, we will convert it into meter. Now, we know 1 kilometer is 1000 meters. So, these many kilometers means just multiply it by 1000. So, you will get it in meters. So, your distance will become 3.84 into 10 to the power, here we are having 5 plus 3, that is 8 meter. So this is the value for D. Okay, children, and the value of G is given to us. So using this value in the formula of gravitational force, we are going to find the value of F. So let's do it. So your F equals to G M into small m upon D square. So we'll put the value of capital G, which is given to us in the question, 6.67, that is 6.7 into 10 to the power minus 11. The value of M is 6 into 10 to the power 24. the value of small m is 7.4 into 10 to the power 22 kg. That is the mass of the moon. And children, the value of d, that is the distance between them, is 3.84 into 10 to the power 8 meter and square of it. So we have just put a square. Right, children? Now what we are going to do in this equation, just I'll tell you the calculation part. What you will do is, all numbers you will bring together and all powers you will take it to one side. So here the number is 6.7, this number is into 6, the other number is 7.4, and in upon you are having 3.84 square, right children? So these are the number part, right? Now let's see the power part. So minus 11, this is 22, that is plus 24, sorry, plus 24, right? Here it is 22, so plus 22, right children? And in the denominator you are having 10 to the power 8 square. So 10 to the power 8 square will become 10 to the power 16. And this 10 to the power 16, when it will come up, it will become minus 16. Right children? So you can solve this, you can multiply and divide this, and finally children, your answer will come to 2.01 into 10 to the power 20 Newton. Thus, this is the force that is exerted by Earth on the moon. Right, children? So, what we did, we substituted the value of G, that is universal gravitational constant. Mass of Earth we have put over here. Mass of moon is substituted over here. And distance between them, we are keeping it over here. Then we are going to keep all numbers together and all powers, 10 to the power, that we will solve separately, and then our final answer comes up to 2.01 into 10 to the power 20 Newton. So children, I want you to solve this calculation by your own, and you will just tell me the answer, that whether you're getting the same answer or not. Right? So this is given in your NCERT. It is given on page number 134. This is a solved example. Right, children? Now let's move further. And now children, these are the exercise question answers. These are the NCERT exercise question answers which are on page number 143. Page number 143 of your NCERT. Question 1, let's read it. How does the force of gravitation between two objects change? What they are asking, how will the force change? F कैसे change होगा? When the distance between them is reduced to half. So distance between the two objects को क्या कर दिया बेटा? Half कर दिया distance को. Right children? Distance को half कर दिया. Then they are asking that what will be the effect on force? Now, we know that force is proportional to 1 upon d square, where d is what? D is the distance between the two objects. Now, what they have done to the distance? They have made the distance half. So, now your new distance is d by 2. आपका जो new distance है, that is what? That is not d now. That has become half. You have brought the objects near each other. Suppose initially they were at a distance of 10 meter. Now you have brought together, we have brought them closer at a distance of 10 by 2, that is 5 meter. Right children? So let's put this value in this equation. We will get F is proportional to 1 upon d by 2. अब d square नहीं लिखेंगे, d by 2 का square लिखेंगे, because जो d है उसकी value change हो गई है, half हो गई है, right? So if we solve this, we will get 1 upon d square upon 4. 4 is in denominator, so it will go up. and we will get 4 upon d square. So if you compare this with this, then you can see that the force has become 4 times. Initially the force was F proportional to 1 by d square. Now the force is F proportional to 4 by d square. So the force has increased. So the force between the two objects has increased by 4 times when you are bringing the objects closer by reducing the distance between them to half. राइट स्टूडेंट? तो फोर्स 4 टाइम्स इंक्रीज हो जाता है जब आपने उसका डिस्टेंस को आधा कर दिया. सो दिस इज योर solved in this is your exercise question answer, question number 1. Here they have used the symbol r. No problem beta, because distance they have given the name as r. You can write instead of r, you can write d, no problem, right? Here instead of r you can just put d. Not a big deal, right? कुछ गलत नहीं होगा because आपने distance को r नाम दे दिया. It's all on you, right? So this is your NCERT exercise question number 1. Let's move towards NCERT exercise question number 2. Children, question 2, let's read it. Gravitational force acts on all objects in proportional to their mass. हाँ, जो gravitational force है वो सारे ऑब्जेक्ट्स पे प्रोपोर्शनल है उसके मास पे. यस, बिकॉज वी नो एफ इज प्रोपोर्शनल टू स्मॉल एम एंड कैपिटल एम. है वो प्रोपोर्शनल, राइट? ओके. व्हाई देन हेवी ऑब्जेक्ट्स डू नॉट फॉल फास्टर देन अ लाइट ऑब्जेक्ट? Why then heavy objects do not fall faster than lighter object? Right, children, this is your question. So this question I'll explain you, but I think this part is left. Acceleration due to gravity, I will explain you this part. So then too I'll explain you a little bit. See children, whenever the object is falling on the ground, it will fall with a constant acceleration, right? Constant acceleration means its velocity as it is approaching the earth, its velocity will keep on increasing, right? बहुत तेजी से वो earth की तरफ गिरेगा. उसकी speed initially, if the ball is in your hand, if you are standing on a 100-story building, आप एक 100-story building पे खड़े हैं, आप वहां से बॉल ड्रॉप कर रहे हैं, तो बॉल इनिशियली आपके हाथ में थी तो उसकी वेलोसिटी इज 0. बट व्हेन यू आर जस्ट ड्रॉपिंग द बॉल एंड व्हेन द बॉल इज approaching towards the earth, its velocity will constantly increase. There will be increase in the velocity. Increase in the velocity means there will be acceleration, and this acceleration does not depend upon mass. Right? So heavy object do not fall faster than light object. Both of them should fall at the same time. Both the objects falls at the same time. But you will say that, ma'am, if I throw a 5 kg stone and if I throw a feather, right, or a piece of paper from the 100-story building, then the stone will obviously fall down sooner, faster as compared to paper. Beta, that is because we are having air in between, and because of that air there is air resistance, और air जो है वो heavier object को oppose कम करेगा as compared to the lighter object, right? This is the condition what we are talking about is in vacuum, right children? If in vacuum you throw a big stone and a piece of paper, then you will see that both of them falls on the ground at the same time. Okay, this is also a good question based on again universal law of gravitation. Let's read the question. What is the magnitude of gravitational force? So what they have asked, force find karna hai. What we have to find? Force, right? Between the earth and a 1 kg object on its surface. So mass of earth is capital M. Mass of object is 1 kg. kg mass hote hain, right beta? And the radius of the earth is 6.4 into 10 to the power 6. Now what he is saying? That the object is on its surface. Suppose this is our earth. This is the center of the earth. So your object is over here on its surface. So distance between the earth, the center of the earth and the center of the object will be this distance, that is the radius. So beta here the radius of the earth will be equal to the distance between the two objects, right? Your first object is earth and other object is an object of mass 1 kg. So m value is this, small m value is this, and this is the value of d. See, instead of no problem, D use karo, R use karo, you can write X, but you should write that R is what? R is the radius of the earth, that is the distance between the two objects. So in this formula, if you don't wish to write R, you can use D, no problem, right? So we can use the symbol D. So let's put the value. So we know the value of G. See in this question, G value they have not given because G value you should be knowing. G value you should be knowing, children. And the value of G is 6.67 into 10 to the power minus 11. So 6.67 nearly they have taken it as 6.7. So let's put the value in the formula of force and we will get, this is our formula for force, G is 6.67 into 10 to the power minus 11. M is the mass of the earth. Mass of the earth is 6 into 10 to the power 24 kg. Mass of the object is 1 kg upon distance between them. R is distance between them. Distance between them is equal to the radius of the earth. That is 6.4 into 10 to the power 6 whole square. Again, you will solve the same way, children. What you will do, all numbers on one side. So the numbers are 6.7, this has come into 6 into 1 upon 6.4 whole square. 6.4 whole square into the powers 10 to the power minus 11, 10 to the power 24 upon 10 to the power 6 square is 12. Right, so you can solve this full number and here it will be minus 11 plus 24 and this plus 12 will go up and it will become minus 12. Right children, and so here if you solve this, this will come out to be 10 to the power 1. Right, so solve this and finally you are going to get the answer as 9.8 Newton. Because we know the unit of force is Newton. Right, children? Sure. Now, this is our NCERT question number 4. NCERT question number 4 on page number 146. Let's read the question. The earth and the moon are attracted to each other by gravitational force. Yes, we know earth and moon. The moon keeps on moving around earth because of gravitational force, right? Does the earth attract the moon with the force that is greater, smaller or same as the force with the moon attracts the earth? Why? So what they are telling, that does earth also attract moon with a force which is either equal, smaller or greater than the force by which the moon attracts the earth? So children, we know according to universal law of gravitation that every two objects in the universe, they attract each other, right? You are sitting on your chair, you are sitting on your bed. So you and your bed, both of you are attracting each other with an equal force and that too in opposite direction. Right children? So similarly, the earth attracts moon, yes, with the force which is equal to the force with which the moon attracts the earth. So both the forces, that is the force exerted by earth on moon is equal to the force, F for force, exerted by moon, M for moon on earth. They are equal, but in opposite direction, and so we are having a minus sign here. Right, children? So next question. If the moon attracts the earth, why does the earth not move towards earth does not move towards the moon? So if moon is also attracting earth, then why earth is not moving towards moon? Because children, the mass of the earth is very big. See, as we had done the same thing, that when the apple falls on the ground towards the earth. But earth does not move towards the apple. Both are applying equal force on each other, right? We saw that time that the mass of the earth is big, so its acceleration is less, right? So same is the answer for this. That is, the earth and the moon, they apply equal forces, yes, but the mass of the earth is very, very large as compared to the mass of the moon. Hence, its acceleration is less as compared to the acceleration of the moon. And so we did not see the earth move towards the moon. Okay, children, this is it.